Welcome back, Calculus Geniuses. The last lesson we talked about the power rule for derivatives, and that actually, in that, we kind of constituted using all of the constant rule, the constant multiple rule, the sum and difference rules, and as you found out, if you did it, pretty straightforward. And this section we're going to specialize in the product rule, not that these others are going to go away. So it says, if you have the product, for product rule, if you have, say, a function of x times a function of x, function of x times function of x, and we're trying to find f's derivative, or we're trying to find the derivative of all of this, what you do is you take the derivative of the first, so somehow we'd have to figure out the derivative of this, which is a topic for later, times the plain old second function, plus the plain old first function times the derivative of the second function. So that's our product rule. You're going to see it in action. One of the big challenges on this one algebraically becomes if we need to simplify. The calculus is a breeze. It's when it turns into algebra. Sometimes calculus turns into pretty challenging algebra. Trust me. If you're an expert at algebra, which many of you are on your way to becoming experts at algebra, this is where that's really going to pay dividends, is calculus oftentimes turns into hard algebra. So here we go. Now, I understand this. You could just FOIL this. We could FOIL this, and to be perfectly honest, finding the derivative might be easier for that, but I do not want you to do that. Eventually, we're going to get functions that it's inconvenient to FOIL. Plus, these are just polynomials. I mean, what are we going to do with this? We can't really FOIL this thing. I mean, I guess we could FOIL that squared, but then we have to distribute the sign into it, and you create a much bigger mess. So I will not accept this. If you FOIL these, it'll just be a missing grade. If you FOIL these and just go term by term like we did back in the last section. So we're going to treat this as we're supposed to. So I'm going to use this notation. We want the derivative of the first, and you might not need to do this eventually, so I'm going to do this. We want the derivative of the first times the just plain second plus the just plain first, better write small, times the derivative of the second. So we get the derivative of this thing is a breeze. 4 times 3, 12, x to the third. What's the derivative of 2? The derivative of a constant, f of x is c, so the derivative of c is 0. Because, again, it's just a horizontal line, and what's the slope of a horizontal line? So the derivative of this first term is just 12x cubed times negative 3x to the fourth plus 3 plus the plain old first term, 3x to the fourth plus 2, derivative of the second, negative 3 times 4, negative 12x to the third. And now we're going to go ahead and simplify this thing. So at this stage we can go ahead and FOIL through, but if we can factor, that might be a good way of doing it as well. So I'm going to factor out of this term and this term. I'm going to factor out a 12x cubed because they both have a 12x cubed to give. That won't always be the case. I'm left with negative 3x to the fourth plus 3 from the first term. And if I factor out a 12x cubed, I still have a negative here, times positive minus 3x to the fourth plus 2. Let's see what that does. I get 12x cubed times negative 3x to the fourth minus 3x to the fourths minus 6x to the fourths, and I've got a 3 minus a 2 plus 1. And now you could distribute that in there if you want, But oftentimes, if we can get everything factored in the end, that's a really good place for us to be. Not certain what the answer key would show on that, but we're definitely going to want things to be in factored form. Why is that? Because we're often interested when slopes are 0, when our rate of change is 0, and if I set this equal to 0, now I can see that x either equals 0 or this equals 0, which would not be too difficult to figure out when this equals 0. Okay, f prime, remembering to write small, but I'm going to do some of these steps along the way now, equals the derivative of the first. The derivative of this is 4 times 5, 20x to the third. The derivative of 4, a constant, is 0, times 3x to the third minus 4. So that's derivative of first times plain old second plus plain old first, 5x to the fourth plus 4. Derivative of second, 3 times 3, 9x squared. Derivative of a constant, 0. Okay, so this depends on what we're looking for here, but oftentimes we want it in factored form. So what can we factor out of both of these two things? We can factor out an x squared. That's all they have in common. Other times we just want to distribute out and have it listed like a big polynomial. But let's go for factored form here. I'm going to factor out an x squared. I get x squared. If I take an x squared out of here, I'm left with a 20x times the 3x to the third minus 4. If I factor the x squared out of here, I still have a 9 times a 5x to the fourth plus 4. So let's see, that's x squared times, this would be 60x to the fourth minus 80x plus 45x to the fourth plus 36, or let's see, x squared times, how many x to the fourths do we have? 105 x to the fourth minus 80x plus 36. And again, you could distribute the x squared through that. Okay, calculus easy, algebra tedious. F prime of x equals derivative of first. That is 8x cubed times plain old second plus plain old first, 2x to the fourth plus 4 times derivative of second, 9x squared. What can we factor out of here and here? Only an x squared. Be a really good time for you to try to wrap this one up and come back and check. That leaves me with an 8. From this big term, it leaves me with one of the x's. It leaves me with the 3x cubed plus 2. Plus the x squared's gone, but it leaves me with a 9, and it leaves me with the 2x to the fourth plus 4. You'll see we'll do some of the heaviest algebra lifting as we go through derivatives that you've done all year. This will be great review for you, because the precision of algebra is absolutely paramount in calculus. As I said, the calculus is not going to cause as much problems for you likely if you're paying attention. It's just a lot of different rules. The algebra is what's tedious. So we get x squared times, let's see, that's 24x to the fourth plus 16x plus 18x to the fourth plus 36. Has kind of the same form as the last one. Or x squared, 24 and 18, 42x to the fourths. I've got a plain old 16x and a plus 36. Now at this time, I didn't check it on the last one, but at this time you could also factor out, if you like, it looks like we could factor out a 6. 6x squared, we get 7x to the, I can't factor out a 6. We could factor out a 2. We get 2x squared, 21x to the 4th plus 8x plus 18. Again, we should be comfortable working with that. I actually would not be surprised if the solution guide doesn't have that as an answer. And maybe they just distribute the x squared all the way through. All right, we should be at that point right now. You should, if you haven't tried going solo on this, probably a really good time for you to try to go solo on number 4. Derivative of first, 20x to the 3rd, just plain second, plus just plain first, derivative of second, and now we ask ourselves, what can we factor out? These 3x to the 4th and 5x to the 4th factors, these are stuck, but I can pull a 4 out and 3 x's from here and here. So that's 4x cubed. What am I left with from here? A 5 times 3x to the 4th plus 5 plus 12 divided by 4, 3, x cubes out, times 5x to the 4th plus 2. So I get 4x cubed times 15x to the 4th plus 25 plus 15x to the 4th plus 6 for a final factored answer of 4x cubed times 15 and 15, 30x to the 4th plus 31. Really useful to put these, to have these answers end in a factored form. You're going to see that soon as we do some applications with this. All right, and f prime, derivative of first, 15x squared, plain old second, 5x squared minus 2, plus plain old first, 5x cubed plus 3, derivative of second, 10x. And that's awesome. That's the calculus. What's hard? The calculus or the algebra? Or at least, what's tedious? Okay, so what can we factor out of here and here? Because I can't factor these. I can take a 5 and an x out. That leaves me with the 3 and x and the 5x squared minus 2. Take a positive out of a positive, we get plus 5x out of 10x. I get 2 times 5x cubed plus 3. Or 5x times 15x cubed minus 6x plus 10x cubed plus 6. Let's see, I've got 25x cubed minus 6x plus 6. All right, if you've been concerned about this, let's go ahead and give this thing a try. Follow the pattern that we've been doing. I'm going to be very similar. Excuse me. Welcome back. Hopefully you tried this. F prime x is, let's see, we've got the derivative of the first, 9x squared, just plain second, 2x squared plus 4, plus just plain first, 3x cubed plus 1, derivative of second, 4x. What can we factor out? Not these, just an x. What are we left with? 9 and an x times 2x squared plus 4 plus the x is gone, 4 times 3x cubed plus 1. Or x times 18x cubed plus 36x plus 12x cubed plus 4, or x times x cubes, I've got 30 x cubes, I've got a plain old 36x and a plain old 4. And as mentioned earlier, at this time, maybe you want to factor the 2 out, but we're in a very useful position. And I want to emphasize why that is. If this was equal to 0, if I wanted to know when the slope of this is 0, one of the solutions is x equals 0. And there may be a couple more, 2 or 3 more solutions here, but one of the solutions we have, the more we can get this factored, the more it tells us the story of that function. All right, you're going to notice that all of a sudden we're taking up some, we've got a whole lot of space for this problem, and moving on into these next. I'm actually going to do 8 through 12 as a second video, but we're going to need that extra space here, you're going to see. All right, y prime. We want the derivative of the first function. That's 4x cubed plus 10x times the just plain second, negative 2x to the 5th plus 3, plus the plain old first, x to the 4th plus 5x squared plus 2 times the derivative of the second, negative 10 x to the 4th. And now we're looking, what can we factor out? Yikes. That's our derivative, but there is nothing I can factor out at this time. So, foiling, I get minus 8x to the 8th plus 12x to the 3rd minus 20x to the 6th plus 30x. Distributing carefully, distributing in a minus. So minus times plus minus 10x to the 8th minus 20x to the 6th. Ooh, is that 20? Minus, I was one step ahead of myself. Minus 50x to the 6th minus 20x to the 4th. And now we're looking for like terms. There's minus 10, minus 8, minus 18x to the 8th. Sixths, minus 20, minus 50, minus 70x to the 6th. Let's see, I've got some fourths. Minus 20x to the 4th plus 12x cubed plus 30x. And I'm not sure about factoring that thing, other than I know for certain that I could take out a 2, and that's going to be it. I'm actually going to take out a negative 2, and I can take out an x. And I get 9x to the 7th, take out the negative, plus 35x to the 5th, take out the negative, plus 10x to the 3rd, minus 6x squared, minus 15. I don't know about factoring this, but I do know that 0 is one of my zeros of this. So it tells a little bit of a story. Now, I'm going to pause at that one. This would probably be a really good time just to go through your homework, at least get those first 6 problems done through your homework, build up some confidence. We're going to have some challenges on the next page just with the algebra, but hopefully the calculus is going to be really, really simple for us. Let me know.